In this video, we're going to go through the basic nomenclature of carboxylic acid derivatives. So we've already talked about how to name carboxylic acids, and the nomenclature of the derivatives is all based on the nomenclature of the carboxylic acid. So just as a little bit of a review, we did our various carboxylic acids. I've listed here carbons 1 through 6. Carbon carboxylic acids. We have the IUPAC names: methanoic, ethanoic, propanoic, butanoic, pentanoic, and hexanoic acids. And you can even go further in the IUPAC names with longer chains. But then for the common nomenclature, we just went up to 6 carbons. And if you just have 1 carbon, that's formic acid. 2 carbons acetic acid, 3 carbons propionic acid, 4 carbons butyric acid, 5 carbons valeric acid, and 6 carbons caproic acid. And the mnemonic that you can use to remember these 6 common names is fact to all people, better value chemistry. So we're going to use this base IUPAC and common nomenclature system to see how we can generate the IUPAC and common names of carboxylic acid derivatives. So we're going to start with acid chlorides. And with all of these, just like carboxylic acid, the carbonyl carbon is going to be carbon 1. And as always, your parent chain is just the longest carbon chain in the molecule. So here's our parent chain here. Okay, so 4 carbons. If we were giving this an IUPAC name, the 4-carbon carboxylic acid is butanoic acid. The 4-carbon common name for a carboxylic acid is butyric acid. Now, to designate that we have not a carboxylic acid, but an acid chloride, or it could be bromide or iodide, we change the IC acid to YL chloride. So no matter which one we're using, we'll drop the ic acid. And the IUPAC parent would be butanoyl chloride. The common parent would be butyryl chloride. Okay, so for the IUPAC name of this, we just have to deal with our methyl group. And that's on carbon 2, so we have 2-methyl. And use the IUPAC parent name, butanoyl chloride. Okay, now if we're using the common nomenclature system, remember we don't mark the carbonyl carbon as anything, but the next carbon out is alpha, beta, gamma, and so forth with Greek letters. So in the common system, we have the methyl group at the alpha position. So we have alpha methyl butyryl chloride. Okay, so if you're using the common parent name, you need to use the alpha, beta, gamma. If you're using the IUPAC parent name, you need to use 1, 2, 3, 4. Okay, now if we have a ring, the ring is basically our parent, and the carbon of the acid chloride isn't counted, or isn't part of the parent. So we have to do this a little differently. We're going to name the ring, and still the carbon where the acid chloride is attached, that's carbon 1. And then number around your ring to give the lowest substituent numbering. Okay, so we can't just change the ending, because the acid chloride carbon isn't actually embedded as part of the parent. What it is instead is attached to the parent. So we need to deal with the fact that it's attached to the parent, and we name this group coming off of the parent as a carbonyl chloride. Okay, so the way we'll generate this name your ring portion first, as you would just a typical cycloalkane. We're going to do, we have an amino substituent at carbon 2. We have 2-amino cyclohexane. But to designate the attached acid chloride, we finish the name with carbonyl chloride. Right here, sometimes you'll see people put a 1 to designate its location. It's not necessary, but IUPAC rules does allow you to put a 1 there if you want. Okay, the next group that we're going to look at are the esters. Now, the tricky part about esters is that on the esters we have these R groups on the oxygen we have to deal with in the name to designate it. Aside from that, we're just going to name it like we would the carboxylic acid and change the ending ic acid to 8. So this first one, the first thing we're going to specify is the R group on the oxygen, which is just a methyl group. It's a CH3. Okay, then our parent chain, we have 5 carbons. Comes from pentanoic acid, but we'll drop the IC acid and add 8, so it'll be pentanoate. So the way we name this, start with your ester R group, which in this case is methyl. Leave a space. If you have any substituents, here's where you would list those. We don't in this case. So now we'll just list our parent. Pentanoate. So the IUPAC name is methyl pentanoate. If you were going to do the common name, just like before, you would use methyl to designate the ester R group, but 5 carbons comes from valeric acid. So you would do, instead of valeric acid, drop the IC acid, you would do valerate. Okay, this next example is a little more complex, so we're going to stick with just the IUPAC naming system. The R group on the oxygen is a 4-carbon chain, that's a butyl group. And then for our substituents, coming off of our parent. Here's our parent chain. Here's our substituents. We have 2 bromo substituents. And they're both at carbon 3. Okay, so we'll assemble our name. Start with the ester R group, butyl, leave a space. Now we'll write our substituents alphabetically, but in this case, we'll just combine our 2 bromos as 3,3-dibromo. And then the 7-carbon parent comes from heptanoic acid. We do heptanoate. So if we have an ester on a ring, it's really the same deal as what we would with the carboxylic acid on a ring. If we had this carboxylic acid on a ring, we would name this as 2-methyl carboxylic acid. Well, just like before, we're actually just going to change this ending to ATE to represent the ester, and we have to designate this ethyl group on the ester. So the IUPAC name for this, we'll start with the R group on the oxygen. Do ethyl, then leave a space, 2-methyl carboxylate. One other thing you might run into, which really isn't any major difference, is if you have a carboxylate with a metal present, where essentially this is the sodium cation and the carboxylate anion, and rather than naming the ester R group, you just name the metal cation. So this would be sodium. 4 carbons comes from butanoic acid. Sodium butanoate. Okay, so amides can be just a little bit more complicated because on the nitrogen we can have the potential for 2 different R groups being attached. But what we're going to do is just name those, if there are any, as N-alkyl substituents, then just alphabetize them with your other substituents. Then, since it's a derivative of a carboxylic acid, you're going to change the IC acid ending, YLIC acid or oic acid ending to amide. And we'll see some different examples. Depending on what the ending is, you have to make a choice of what you have to drop. So in this case, this is just a simple one. We have a 5-carbon chain. Okay, so if we're dealing just with a carboxylic acid with 5 carbons, we have pentanoic acid, which would be the IUPAC, or the common name, valeric acid. Okay, so as for the ending, for the pentanoic acid, we have to drop the oic acid and change that to amide. Pentanamide. And be careful, it's not pentamide. So make sure you keep that A in. So it's pentanamide. Okay, but with the common name, we don't have an oic acid to drop. All we have is an IC acid to drop. So that's what we're going to drop there. And this becomes valeramide. If you had any substituents on here, you would have to put those in front of the parent names. If we had any R groups on the nitrogen, we would have to deal with those as well. But this amide doesn't have any of that, so we don't have to worry about it. So here's a couple of more complex examples. This first one, we have methyl groups on the nitrogen. So we have an N-methyl and another N-methyl. And then this particular amide, if we do the IUPAC, 2 carbons, it would be ethanamide. If we did the common name, it comes from formic acid, it would be formamide. So for this, what we can do is just like we would do if we had 2 methyl substituents on carbon 3, you would do 3,3-dimethyl. What we'll do here is we'll do N,N-dimethyl. And we could do ethanamide or formamide. The common name's actually more common for this one because this is actually typically abbreviated, this N,N-dimethylformamide, as DMF, which is a common organic solvent. And that's what we usually just call it, is DMF. Okay, in this second example, we have a propyl group on the nitrogen. We have N-propyl, and then here's our parent. On carbon 4, we have 4-methyl, and then the parent chain here, 5 carbons, let's just do IUPAC. Would be pentanamide. So now take your 2 substituents and alphabetize them. Methyl comes before propyl alphabetically. So we do 4-methyl, N-propyl, and the N tells us it's on the nitrogen, and then the parent, pentanamide. If it's on a ring, we name it as carboxamide, and that just comes from, if you have a carboxylic acid on the ring, you'll name the ring followed by carboxylic acid. Well, here we drop the YLIC acid and change that to amide. So this one, here's carbon 1. Not really a big deal since we don't have substituents to deal with. But we have cyclobutane carboxamide. If we had a methyl group on there, we would have to name it as the methyl cyclobutane carboxamide. Okay, the last carboxylic acid derivative that we want to look at naming, and we're just going to look at some simple molecules here. They're the anhydrides. What you want to do is consider the two acids that essentially came together to form the anhydride. For example, in this first one, if we took 2 molecules of acetic acid basically lost water due to dehydration and connected them together, we would form the anhydride. So the acids that we start with, you can either use the common name, which would be acetic acid, or the IUPAC name, ethanoic acid. So for the anhydride, what we'll do is just name the acid, but we won't keep the acid ending. We'll replace that with anhydride. So for the common name, we have acetic, and we say anhydride. For the IUPAC, we have ethanoic anhydride. Okay, the second example is an unsymmetrical anhydride. So basically you have to figure out the corresponding 2 carboxylic acids you would have used. Let's just do IUPAC for this one. Okay, this portion comes from a 3-carbon carboxylic acid, which is propanoic acid. The other side comes from a 4-carbon carboxylic acid, butanoic acid. So now we just alphabetize these two. So butanoic, propanoic, not acid, but anhydride.